this lesson, we're going to be talking more about sample space, and we're going to be talking about how to use the counting principle to find out how many outcomes are possible in that sample space. Tree diagram and listing helped us see what the outcomes were. In this one, we're just interested in how many outcomes are possible. So there's two questions we're going to ask ourselves. The first question is, how many trials or actions are going to happen? For example, how many times are we going to roll a die? How many items of clothing are we going to choose? That kind of thing. How many different actions are going to happen? And then the second question is, how many outcomes are possible for each one of those trials or actions? So in this first example, we have a sandwich shop that has 3 types of sandwiches: ham, turkey, or chicken. So here it looks like we are choosing a sandwich, which means there is only one action that's going to happen. So I'm going to draw one blank. And how many outcomes are possible when I choose that one sandwich? Well, I can choose ham or turkey or chicken. So there are 3 possible outcomes. That's pretty basic, right? Number 2, the chess club decides when to meet. The possible days are Tuesday, Wednesday, or Thursday. So they're going to make one decision, and that's what day to meet, and there are 3 possible days to choose from. Now, when more things start happening, this gets a little bit more involved. So here, the chess club is going to decide where to meet for practice. So now they need to know, when to meet, but now we have days and we have times. So they're going to have to make 2 different decisions. The first thing they're going to have to choose is a day, and the second thing they're going to have to choose is a time. Well, there are 3 possible days to choose from, so we're going to put a 3 in the days blank. And then there are also 3 possible times to choose from, so we're going to put a 3 in the time blank. And then if we multiply those 3's, we find that there are 9 possible outcomes. In question 4, it says a button is pressed, a computer outputs a random odd number greater than 1 and less than 9, and you press that button twice. So how many actions are happening here? Well, there's going to be 2. There's the first press, and then there is the second press. Now we want our number to be greater than 1 and less than 9, and it has to be odd. So it's got to be bigger than 1, which means it's not 1. It could be 3, 5, 7, 9. Well, it can't be 9 because 9 isn't less than 9. So we have 3 possible options. So we have 3 outcomes possible for the first press, 3 outcomes possible for the second press, and we multiply those together and we get 9. You may remember that question from the tree diagrams page where we said we could get a 3, a 5, or a 7, and then off of each of those was also a 3, a 5, or a 7. So you see it was 3, and then there were 3 off of each of those. So that's where the 3 times 3 is coming from. You get 9 possible outcomes there. Number 7 says, a jewelry store sells gold and platinum rings. Each ring is fitted with a ruby, a sapphire, an emerald, or a diamond gemstone. So here it looks like we have 2 choices. We need to choose what kind of metal we want. So the first choice is going to be the metal. And then we also need to choose the stone. So for metal, how many outcomes are possible? Well, we have gold and platinum, so there's 2 possible outcomes. For stones, we have ruby, sapphire, emerald, or diamond. That's 4 choices. So there are going to be 8 different ways we can select a ring. Number 10 says 6 books need to be placed on a shelf, and you randomly arrange the books on the shelf from left to right. So we're actually on this one, we need to put all 6 books on the shelf. But when you think about this, I want you to think about doing this one at a time. Your first choice is which book to put in the first spot. Then your second choice is what to put in the next one. And then the third, the fourth, the fifth, and the 6th. Now, when we go to select that first book, how many outcomes are possible for that first book? Well, we have 6 books to choose from. So let's say our books are A, B, C, D, E, and F. So we have 6 to choose from for that first spot. So there's 6 possible outcomes. But once we've put a book there, we can't put that book there in the second spot. So now we only have 5 books to choose from for the second spot. Once we've chosen a book for the second spot, we have 4 books left to choose from for the third. Then we have 3 for the fourth, 2 for the fifth, and the last one, there's only 1 book to choose from. And then we can multiply these numbers together. We get 720. Okay, for our last example, we have, 8 rooms in a house need to be painted, and each room can be painted either white or yellow. So I want you to think about how many decisions are going to need to be made. We have 8 rooms, and we have to choose a color for each of those rooms. So there are going to be 8 separate decisions that are made here. The first room, the second room, the third, the fourth, the fifth, the sixth, the seventh, and the 8th. We have to make a decision for each room. And each room can be either white or yellow. So there are 2 outcomes possible for each of these rooms. So you might notice we're multiplying 2 over and over. So we could write this as 2 to the 8th power, or we could calculate 2 to the 8th power. Either way. There are 256 ways we can select for the 8 rooms to be painted, either white or yellow. So when you're thinking about using the counting principle, remember that the counting principle is used to find the number of total outcomes. That's what it's used for. And the 2 questions you want to ask yourself are how many trials or actions are going to happen and how many outcomes are possible for each of those. And then you'll use multiplication to figure out the total number of outcomes.